Find the value of x. The angle x over there is angle AED. So this must be equal to the angle. What is the corresponding angle for AED? PTS, good. PTS. So let's search. Where is PTS? PTS, 120. So here we have 120 degrees. What is the value of y? Let's search for y. Y. Oh, y is over here. It is represented by ED. What is the corresponding side to ED? TS. So let's search for TS. TS, 4.5. So this is 4.5 cm. Find the length of EA. This one over here. So how do we find the length of EA? Do you want to find the corresponding side? EA, so TP, is it given? TP also not given over here. Then how? Yeah, I heard minus, so you are trying to use the parameter, right? So 24. 24 minus 4 minus 5 minus 4.5 minus this one. What is BC? 3.5, okay. BC is equals to QR, which is 3.5. So EA must be equals to 24. 24 minus 4 minus 3.5 minus 5 minus 4.5. Get the answer. Okay, I'm too lazy to calculate it out for you. Do it yourself. I'm sure you can get the correct answer. Now for practice 3. Two diagrams. This time they are quadrilaterals, four-sided figures. They are congruent. 113 degrees for STU. RS is 18. When you're given this type of question, right, just go through line by line. Okay, STU is 113. STU, this is 113. RS is 18. RS is 18. Yup, it is stated. QR is 12. QR is 12. PS is 9. Okay. PSR 62. PSR 62, done. QRS 74. QRS 74. Okay, all the information is found inside my diagram. Okay, I'm saying this because sometimes they may, for example, leave this out in your diagram. Then if you do not tally the information, you won't realize that it is supposed to be 9. So you put in all the missing information into your diagram. In this case, they're nice to you, they put in everything for you already. So find the length of PV. PV. Think about it. Is there a corresponding side of PV? Based on the name, you can tell, right? Have or not? PV. Is there a PV? Don't have. Okay. But that's what I need to find out. What do you think you require in order to find PV? Based on the diagram. TV. TV. How will TV help? Okay, I heard somebody say SP. If you know SP, it is possible for you to find PV, right? But I need one more piece of information besides SP. SV. Now, as long as I know SV, if I know SV and I know SP, then I can subtract and get the answer, right? Okay, then what is SV right now? So part A, SV equals to SV over here equals to SR, which is 18. So this is 18 cm. Then SP, it's already given to us is 9. So PV must be equals to SV minus PS, which is 18 minus 9 equals to 9 cm. What this also means is that P is the midpoint. P is the midpoint of SV. This is for part A. Angle PQR. PQR. For part B, what is the corresponding angle to PQR? From the names of the quadrilateral, what is the corresponding angle? PQR. So TUV. Is that given to us? TUV. Okay, this is the angle, which I don't know what is it. Then how do I continue? I show you one more trick that I have. Instead of going 74 degrees equals to angle SRQ, I can just call it R. It's angle R. So I find, R is over here. The third letter, so correspondingly it must be V. This is also 74 degrees. Okay? Then I want to put in my 62 degrees. 62 degrees is my angle S. Over here. And over here. So this is also 62 degrees. If you want to use this shortcut, you must be very sure of what you are doing. Now that I have put in all the angles that I know. Oh, no, there's one more. T is 113. If T is 113, then P must also be 113. Now I want to find angle PQR. This is the angle. So how do I find it? What? 360? What do we do with 360? 360 minus 113 minus 74 minus 62 degrees. But why 360? Angle sum of, what is this? Quadrilateral. Quadrilateral. Okay, go ahead and spell properly. So it's the angle sum of quadrilateral to give us 111 degrees. And the last one, QPV. QPV. Okay, I filled in everything that I can already. So what is angle QPV? How do we find it? Again, 360. Okay. 360 degrees minus 180 minus 113. Then what is the reason now? Yes, angles at a point. So this answer will be 67. So in this topic, you need to know all your reasons again. Then let me do a recap at the side. F, U, what's the next one? Z. Oh, okay. So what do we learn from this? These are parallel lines. A and B. A and B. A and B. So the first one. Good. Okay, the first one is corresponding angles. So from here we say that angle A equals to angle B. Corresponding angles, parallel lines. Okay, that's for the first one. For the next one, what can you tell me about angle A and B? Angle, what is the relationship? A plus B equals to 180 degrees. Interior angles, parallel lines, yes. Interior angles, parallel lines. Okay, what about this? Somehow students like this a lot. What is the relationship between A and B? Relationship in an equation, what is it? A equals to B. So alternate angles, parallel lines. What does this O represent? Okay, so if I go one round, total the angle will be 360 degrees. Angles at a point. This is the reason. Then we've got A and B over here. What is the relationship? Let me put in another one. A, B, and C. What is the relationship? A plus B plus C equals to 180 degrees. Reason? Adjacent angles on a straight line. What else have we learned? Triangles, right? Triangle, I've got A, B, and C. So angle A plus angle B plus angle C, 180 degrees. Angle sum of triangle. Can? So this is our summary. Next question, last one. I think it's the last one. Yep, it's the last one for congruency. We've got two shapes that are congruent again. You can. How do you think we can go from the original to the image? What do you think is the transformation to go from the original to the image? Is it a rotation? Is it a rotation? Or is it a rotation plus something? You think about it. Try and visualize. If you rotate it, are you going to get that shape? Are you going to? Rotation plus reflection, or reflection plus rotation, same thing. You first need to reflect it. So it's like reflect this way. Just like how some of you are comparing your triangles just now, you have to flip it over, then you look underneath. Okay, so you flip it, then you rotate it to get that. So when we do that, it will be congruent. That's just for fun. Right now, two equations in terms of x and y. So this is quite a different question. Write equation in terms of x and y. So any idea how we can start? 3x plus 2y. 2y equals to 4. Okay, how do we know? I mean, it looks like it lah, but we need to convince ourselves from the name. So 3x plus 2y, that is our CD, right? Okay, CD over here must be equals to RS. Okay, same. So that is our first equation. Equation number 1. Equation number 2. What is it? Y minus 2x equals to? So y minus 2x is AD. So AD must be the same as PS. PS. Oh, it's 9. I nearly put 8 just now. I looked at the diagram, I thought it was 8, but luckily I checked. It is supposed to be 9. Equation number 2. Part A done. Part B. Solve. Would you like to use substitution, elimination, or draw graph? Which one? Substitution. Okay. Which equation do we start with? 1 or 2? 1 or 2? One of it is easier than the other. Let's start with equation number 2. From equation number 2, what do you want to make the subject? Y. Good. Y equals to 9 plus 2x. Let's call this equation number 3. Let us substitute this into 1. Yeah. Okay, so 3x plus 2, 9 plus 2x equals to 4. 3x plus 18 plus 4x equals to 4. 7x equals to negative 14, yeah, okay. X equals to negative 2. I got the value of x. Sub into which equation? 3, yeah. So that I can get y straight away. Y equals to 9 plus 2 times of negative 2, which is 5. So my final answer, x equals to negative 2, y equals to 5. Simultaneous equations are standard types of question. You will always be able to solve them using substitution.